Students, introducing myself, Arjun Kumar, Department of Chemistry, DAV Public School CCL Giridi, is here with chapter number 2, the structure of atom. I have to teach second chapter is a structure of atom. Students, this structure of atom you might have learned to some extent in class 9 also. There you might have heard the name atom, their constituents electron, proton, neutron, etc. And at the same time Dalton's atomic theory also. But here the same chapter is given in extensive form. I mean in detailed form. The content is detailed in structure of atom. So let us recap all these things that we have discussed earlier in class 9 or we have gone through in class 9. Okay, in a structure of atom, first we discuss Dalton's atomic theory. You might have heard, you might have learned Dalton's atomic theory. Dalton's atomic theory tells us, actually there are 6 points, many points, at least 5 or 6 points we generally discuss in Dalton's atomic theory. The first point is an atom is ultimate part or ultimate particle of an element which cannot be divided further. That means it is an indivisible particle. So if we consider that Dalton's atomic theory, then an atom has no structure. That means an atom is structureless. Then how we can have the structure of atom? So, with the discovery of electricity, radioactivity, X-rays, etc., an atom has been divided into many segments, nearly 35 particles. However, some of the particles of atom is something like electron, proton, neutron, positron, then muon, pion, etc. Many particles are there and you will get to know later on. However, the most fundamental ones, they are electron, proton and neutron. Everybody knows. Now, the discoverer of electron, proton, neutron, everybody knows, and I hope you must be knowing. For electron, it was J.J. Thomson. For proton, Goldstein. And for neutron, James Chadwick. So these are the discoverers for electron, proton and neutron. Even in class 9, we generally discuss with the students how electron was discovered, proton was discovered and neutron was discovered. If you like to know once again, then I can tell you that also. In brief, discovery of electron. Discovery of electron. You know, the experiment was carried out in a discharge tube. This is made up of glass. Here is cathode. Here is anode. And a gas is taken under very low pressure. Very low pressure. That is 0.01 mm, or even similar to this low pressure and very high voltage, something like 10,000 to 20,000 volts. So this is the condition. We have to maintain very low pressure and very high voltage. At this condition, the electricity begins to flow through this gas, and this becomes conducting, and we just get the invisible rays. They are coming out of cathode towards anode. They are moving from cathode to anode, and finally they were named cathode rays. Cathode rays. Now, with the help of their properties, we confirm the stream of cathode rays as a stream of cathode rays is the flow of electron. Is the flow of electron. So, electron was discovered through discharge tube experiment, where such type of arrangement is made. Only two things are very important. We have to maintain very low pressure and very high voltage, that is 10,000 to 20,000. Otherwise, you know, the gas is bad conductor in nature. So how we can pass electricity through it? It is impossible. So we must have to maintain these two conditions. Similarly, discovery of proton. Similarly, discovery of proton is done in the same discharge tube, but here only difference is that we have to take the perforated cathode in the middle of the discharge tube, and here we have to take anode. Here is cathode negative. So what happens? Here also we have to maintain the same condition. Very low pressure. And very high voltage, similar to the experiment for discovery of electron. Now, what happens? Again, cathode rays are coming out towards the anode, and one of the characteristics of cathode rays that we consider here, they have tendency to ionize the gas wherever it is passed. So here is the trace of gas. This gas becomes ionized. This gas becomes ionized, or here we can write ionized gases. Ionized gas. Now, this ionized gas or positively charged ion, they get attracted towards the cathode, and this is just flowing from anode to cathode like this, and finally it is named anode rays. And when we go through the various properties of anode rays, then a stream of anode rays, is similar to the stream of or the flow of proton. So here, similar to the discovery of electron, here we have to discover the proton in the same discharge tube by making slight change in cathode. Earlier it was taken complete cathode, here is perforated cathode. Here this cathode is taken perforated. Perforated means having a small holes in it. So this is how to discover proton. Discovery of neutron. And for this, we take a sheet of beryllium. Here is the sheet of beryllium metal, and here we have to bombard with by alpha. So the sheet of beryllium is bombarded by alpha rays to get neutron. This can be represented by an equation like this: a sheet of beryllium plus alpha ray. This gives C6 12 carbon, and this is neutron having 0 charge and 1 mass. So this is already balanced: 9 plus 4 13, 12 plus 1 13, 4 plus 2 6, 6 plus 0 6. So this is how to discover neutron in an atom. We have done. Now we make a chart which gives us the idea of mass and charge of fundamental particles. So here we have to write mass and charge of fundamental particles. And for this we have to draw a chart by making some column. Here is name and symbol of subatomic particles, here is a relative mass, then absolute mass, the relative charge, and then absolute charge. This table will be very important. So in the first column we have to take the name of first fundamental particle or subatomic particle, that is electron. It is symbolized as E. The relative mass of electron is 0.00055 U, and this is very close to 0 U. Absolute mass is 9.1 into 10 to the power minus 31 kg, and its relative charge is -1, and absolute charge is 9.1 into 10 to the power minus 19 coulomb. So here is 1.6. Here is 1.6 into 10 to the power minus 19 coulomb. Similarly, for proton, it is represented by P, small p. Here is 1.0073 U, and this is very close to 1 U, and its absolute mass is 1.674 into 10 to the power minus 27 kg. Its relative charge is +1, and absolute charge same, 1.6 into 10 to the power minus 19 coulomb. And finally, for neutron, it is little heavier than proton, slightly heavier than proton. So this is 1.0087 U, and very close to 1 U, and this one is 1.676 into 10 to the power minus 27 kg, and this has no relative charge, no absolute charge, because this is neutral in nature. So this chart will give us information about mass in terms of relative mass and absolute mass, and charge in terms of relative charge and absolute charge of subatomic particles, that is electron, proton and neutron. And thereafter we have some questions based on this topic. The question is, question number 1, you must write question number 1. Write various properties of a cathode rays, B anode rays. And second question is also important. Why is electron considered universal constituent of all matter, So you must answer these two questions, and any sort of doubt if you are facing, you must have discussed with me in that class. Okay, thank you.